Gentlemen, this is Unit 3, Standard 2, Module 5. We are going to be focusing on what we call a field goal problem. All right, so this isn't necessarily someone making a field goal, but it's like someone attempting to make a field goal. So it says a firefighter 50 meters away from a burning building directs a stream of water from a hose at an angle of 30 degrees above horizontal. If the velocity of the stream is 40 meters per second, at what height will the stream of water strike the building? So I'm going to draw kind of um, a picture for this. So you have this stream of water, it is going, and it's going to hit this building. Now, we don't know if it happens before or after the Y max. We just know that it strikes this building. And the building is 50 meters away. All right, so what we're really trying to find is we're trying to find dy at that spot, right? We're trying to find what height from here to here is this going to hit. All right, so the way we do that is simply like every other one. We've got to break this down into what's the x components, what's the y components, and what is it that we can find from here, right? Okay, so first off, let's find the initial velocity. So this is going 40 meters per second. The angle is 30 degrees above horizontal. We can go from here. So um, we have VIX. We can solve that with 40 cosine 30. VIY is 40 30. All right, good. So from there, now let's go to what do we know in the horizontal? What do we know in the vertical? So moving these over here, uh, what is it that we know in the horizontal? So let's start with dx. So dx, we actually do know it's 50 meters. Vix is going to be 40 cosine 30. And when you put that into your calculator, so grab your calculator, grab 40 cosine 30, you're going to get 34.64 meters per second. All right, BFX is also going to be 34.64 meters per second. And the reason for that is that 8x is actually 0 meters per second. It's not accelerating in the horizontal direction. Good. We don't know the time. All right, we actually don't know the time in this case. So let's go ahead and move on to what's going on in the y. So in the vertical, okay, dy is what we're looking for. So let's circle that. VIY we can determine based off of 40 sine 30. So 40 sine 30 is going to give you 20 meters per second. VFY, in this case, we actually don't know what that is, right? So this isn't one of those scenarios like ground to ground where it would be negative, or at the max height, it's not zero. We don't know what VFY would be, but we do know what AY is. That's negative meters per second squared, and we don't know what time. All right, so take a second to look at what is it that you know. So first off, we're trying to find dy. All right, and take a second of what you know in the y motion. So in the vertical motion, you only know two things. You know the initial and the acceleration. We need one more. Okay, so what's one thing we can pretty much solve for, or that we've solved for in all the other problems, right? It's time, right? So if we can solve for time in the x, we can hopefully move that over and use that in the vertical motion. Now, the x is going to need 4. And do we have 4 knowns in the x? We do. Yeah, yeah, VFX, and AX. We actually have all 4 knowns we can solve for time. So using our go-to equation, sorry about that. Using our go-to equation, d is equal to di plus 1 half squared, we can solve for time. Now remember, acceleration is 0, so that term cancels. You have x is equal to vi times time. So ts is 50 is equal to initial velocity in the x direction is 34.64, and then you have time. So how do you solve for time? Divide by 34.64, divide by 34.64, and you get 50 divided by 34.64. Going to give you time will be 1.44 seconds. All right, so now we can move that over to the y. So now this time is no longer unknown. We actually know what that is. We have 1.44 seconds is our time. Okay, so dy can now be found. Now you have three nodes. So what equation use? So what equation has initial velocity, acceleration, time, and displacement? So it's actually the same equation. Distance is equal to VIT plus 1/2 AT. So dy will equal 20 times 1.44 plus a 1/2 times a negative 9.8 times 1.44 squared. All right, so let's simplify this. 20 times 1.44 will give you 28.8 plus a negative 4.9 times 1.44 squared is 2.0736. All right, and this is all going to be dy. All right, so negative 4.9 times 2.076 will give you a negative 10.16. So 28.8 minus 10.6 will give you your final answer, and that happens to be 18. So again, I'll write that down here. The final answer is 18.64 meters. That is the height at which this will be hit. 18.64. All right, good. So go ahead and try the two problems that are on this module, and I will see you guys on Monday. Bye.